Hey everyone, today we're going to be taking a look at our first day from Unit 10, which is going to be revolving around three-dimensional figures. So you can see this first day is just going to be an introduction to 3D figures. From our learning objectives, we see the 4 targets for today. We want to be able to define what a net is and the three-dimensional shapes that they represent. We want to be able to define and identify various parts of three-dimensional figures. We want to be able to classify three-dimensional figures. And lastly, we want to be able to define and identify cross-sections of three-dimensional figures. So in the warm-up list here, what I want you to do is just take about 30 seconds here, and I want you to write down as many three-dimensional figures as you can. I'm going to ask that you pause the video, so then that way, once you're done with your list, you resume and see how you compare. So our three-dimensional figures that we'll be learning about will be prisms. Now those could be triangular prisms, rectangular prisms, a lot of different types of prisms, and we'll go into more depth over the next couple days with those. Cubes, which is a special type of prism. We've got pyramids. We've got cones. We've got cylinders. And then we have spheres. And then very closely related to spheres would be hemispheres, which would be half of a sphere. If you came up with any others, that's great, but this is the list that we're going to be learning about over the course of this unit. So, with that being said, let's first define what a three-dimensional figure is. By definition, a three-dimensional figure is a solid that can be measured in 3 different directions. Last unit, when we were learning about area, we've learned about a base, which was typically side to side, and a height, which was typically up and down. But something that two-dimensional shapes didn't have that three-dimensionals do is that third direction, which in this case is going to be a front to back, which will kind of dictate more so on an angle when looking at images of three-dimensional figures. So the first part of a three-dimensional figure, and this kind of makes that relation from a 2D shape to a 3D shape, is what we call a net. So a net is a two-dimensional representation of a three-dimensional figure. A way you can kind of think about it is if you were to take a 3D shape and open it up or unwrap it, and then just kind of lay it flat on the ground, what would that look like? So you can kind of see it's an opened up version of a 3D shape. A very, very real life connection to this would be like if you were to take a box and then break it down, which a lot of people will do to make more space. They'll break a box down so that it lays flat. That's kind of the idea as to what's going on here. So when we see this first example here on the left-hand side of what a net is, we can see that this rectangle here labeled as the front corresponds to this rectangle right here, the front of the three-dimensional shape. This left side right here would correspond to this left side over here. This part right here would be the bottom when folded back in. This top part when folded would correspond to this top part here. This rectangular piece would correspond here, and then the last part would be the back. And what we can see is the back is the same size as the front, the top is the same size as the bottom, the left is the same side or same size as the right. Okay? So the left one is what we call a net. This right side is the three-dimensional solid that it represents. So here are some examples of questions you may be asked. One of them, or these 3 questions, determine the 3D shape that is created by the net. So in this first one here, we want to think about what three-dimensional shape would look like this if we opened it up. And so a way to do that is just kind of use some visualizing to say this piece would fold in, this point would fold in, this point would fold in, this point would fold in, and essentially these 4 points would all meet at one spot above the square, this would turn into a pyramid. Okay. So if you'd like, you can pause the video for a couple seconds while you write out what you believe questions 2 and 3 are going to turn into. Otherwise, just continue to follow along. For question 2, we have a circular top and a circular bottom, and we can see that the rectangle would kind of wrap around those circles. This would end up creating a cylinder. Lastly, we've got our shape here where we've got the triangle on the left and right hand side. And what would kind of happen is those two would fold up so that these points here and here would be facing upward. This middle rectangle would wrap around to this side, and then this top or bottom rectangle would wrap around to this side, and what we would end up seeing is what we call a triangular prism. I won't do it, but if you'd like to click on that link that says real life example, it'll take you to a picture of something that will have that same shape in real life. Okay. Now, this first day is going to be very, very heavily based in vocabulary because the rest of the unit is going to correspond back to these vocabulary words. So one important word for today and for the rest of this unit are what we call the base or bases. These are the, for lack of better terms, the bottom side of the three-dimensional shape when the shape is facing upright. And you can see that word bottom is in quotations, and that's because sometimes the shape won't be facing upright. If it's laying on its side, now the base might be on the left or the right side of the picture. But assuming that the shape is standing upright, the base would be the bottom. Now, we have an additional note here. We can see that prisms and cylinders actually have two bases, a top and a bottom. So in this case here, we would have this top base, and then we don't see it, but realistically there's a second base that this prism is standing upright on. Now, pyramids and cones would only have one base because the opposite side of the base just comes to a single point. Okay. Now, prisms and pyramids are named by the shape of their base. So in this case, we can see that this base has 6 sides to it. So we would call this a hexagonal or hexagonal prism. So again, if it had 5 sides, that would be a pentagonal prism. If it had 8 sides, it would be an octagonal prism. So pyramids and prisms are named based on their shape of the base. Now, cylinders and cones will always have the same shape for their base, and that's going to be a circle. So cylinders have circular bases, cones have circular bases. Now, the faces are all sides that are not bases. So for example, this side highlighted in green would be an example of one face. Okay, and there are many faces on that prism, but there's just one of them. The edges are the segments that are created when 2 sides or 2 faces come together. So for example, this segment highlighted in blue is what we would call an edge. It's where this left side and this front side come together. Now, shapes with circular bases do not have edges. So for example, a cylinder does not have any edges. A cone does not have any edges because there's no spot where 2 sides are coming together. Next term is our vertex. And a vertex is a point where 3 or more sides come together. So for example, this point right here would be one example of many vertices in this prism. This would be the combination of the left side, the back left, and the top all coming together to create one point. Now, shapes that do not come to a single point anywhere will have no vertices. Long story short, this would be your cylinder, your hemisphere, your sphere. None of those come to a single point anywhere, so there are no vertices for those. Okay. And then lastly, we have our height, which can also be referred to as an altitude, and that is the perpendicular distance between the bases, or if there aren't two bases, if it's a cone or a pyramid where there's just one base, it's going to be from the base up to the highest vertex. So in this case, we can see the height is just this measurement from the bottom base to the top base going straight up and down perpendicular. Okay. So a lot of vocabulary there: bases, faces, edges, vertex, height, and altitude. We're going to continue to use these words all throughout the unit, so if it takes a couple days to get used to it, don't worry about it, you'll get there. So, vocabulary examples that you may be asked to do. No math required as far as numbers go, but it's just naming and identifying different parts. So, the first line when it says classify, we want to just name what type of shape is it, and we want to be as descriptive as possible when we do that. When it asks for the vertices, we want to list any points or any areas on the shape where it comes to a single point. When it asks for the edges, we're looking for segments of where two sides come together. And lastly, when it comes to bases, we essentially want to just say what shape the base is. So, in this case here, classification, we can see that it's a pyramid. It comes to a single point up on top. There's one base. And when we look at the shape of the base, we can see that it has 6 sides. So this would be an example of a hexagonal pyramid. Okay, we don't want to just say pyramid because we could be more descriptive than that. We always want to be as specific as possible. As far as the edges go, there's quite a few. So AF is an edge, FE is an edge, and these letters are interchangeable. Okay, the order doesn't matter. ED is an edge. We could also say DE. DC is an edge, or CD. BC is an edge. AB is an edge. Now, those are just the edges along the bases. We also have all of the ones that are going upright. So AT, FT, ET, DT, CT, and BT. These are all edges. It's all of the segments within the shape. Next, we can see that the base is going to be a hexagon. And lastly, I forgot to list it down here in our list, but it does ask for the vertices as well. So the vertices are just anywhere where the shape comes to a point. A, B, C, D, E, F, and T. Those are the vertices. Okay? So at this time, if you'd like to pause and try the last two examples on your own, you may. Otherwise, if you want to just continue to follow along, you can do that as well. Classification for number 5, this is a cylinder. And as I mentioned before, cylinders have no edges. There are no segments anywhere in this shape where two sides are coming together. Okay, we've got curved areas for the circular bases, but no straight segments. Okay, the bases are circles, more specifically circle A and circle B, and there are also no vertices because our shape is not coming to a set point anywhere. Lastly, this classification for number 6 is going to be a triangular prism, similar to the net that we had in example 3. We can see that we have one base here, triangle DEC, and the other triangle GHF. Those are the two bases. This is an example where the base is the front and the back now because the shape isn't standing upright. So the bases, we already mentioned, those are going to be triangles. The edges are all of our segments. CD, CE, DE. Go to the other triangle, FG, FH, GH, and then lastly the connector segments, DG, CF, and EH. Lastly, all of our vertices are just anywhere where the shape comes to a point. D, C, E, G, F, H. So here are some examples where, again, we're just starting to put our vocabulary to use. The classifications, the edges, the bases, the vertices. Okay? Now, the last thing we're going to talk about today is what we call a cross-section. A cross-section is the two-dimensional shape that gets created when cutting through a three-dimensional shape. So again, this is now starting 3D and bringing it back to 2 dimensions. So we've got a good illustration here of a triangular prism, and we can see that knife is kind of cutting through the center, and this shape outlined in red that ends up getting created on the inside is a triangle. So the cross-section of that object would be a triangle. It's the shape on the inside after we cut it open and look on the inside. I thought this was a really good example I found online as well of just a piece of celery, where if you were to chop a piece of celery and look at the inside, you would see this arc shape right here. That is the cross-section of a piece of celery. It's what two-dimensional shape is on the inside after we were to open it up. Okay, so for example, here's that triangular prism that we just saw in the notes above, and we can kind of visualize that if we were to cut through it, we would see this triangular shape on the inside. So it's just a triangle. We're not mentioning the 3D shape. We're not saying it's a triangular prism. We're saying what flat two-dimensional shape would we see when we looked inside. Okay, so if you want to try examples 8 and 9, you can pause this and check when you're done. Or if you want to keep following along, just continue to watch. If we were to slice sideways through a cylinder, we would see something that looks like this, and that would be a circle. That would be what the inside of the cylinder looks like when we cut it that way. And lastly, we have our pyramid, where if we were to cut it sideways, we would see something that looks like this, and that would be a square. Okay? So cross-sections are the two-dimensional shape that we would see if we were to cut or through the three-dimensional shape and see what's left inside. So if you have any questions, please feel free to email me or reach out through Schoology, and I'll be more than happy to address those the best that I can. Good luck with that assignment tonight. Get that submitted as soon as you can, and we'll talk to you later.